This actually here is the video work from our last lesson on how to determine which trig ratio to use when you're actually dealing with these trig when you're solving for sides and right triangles. Okay, let's go ahead and do one more example problem here where we have to solve for two sides. Okay, well, let's say we have the triangle and we have this. Let's say this is 15 feet. And let's say this is y feet, and let's say this is x feet. Okay, well, this is my 90-degree angle here. Okay, and let's say angle theta in this case would be 30 degrees. Okay, perfect. Now, what I want to do here, I want to actually find the length of x and y. Okay, well, looking from this from angle theta, what is x? Well, x is your opposite because it's opposite of you, right? So x is your opposite. Now, what is y? Y is next to this angle. It can't be this side here, even though this is next to it, but this side is the hypotenuse. So it can't be that, right? But what is this angle? So it must be the ADJ, the adjacent. Okay. Now that we have this information, let's find y first. Let's find y. Let's find x first. Let's go ahead and find x. If we're looking from this angle here, now another thing, it doesn't really matter which one you find first, but let's go ahead and find let's find x first. So if we're looking from our theta degree angle here, or angle theta, and we want to know what x is, we know it's opposite. Well, in order to solve for something, I must know something. So I must include the side that I know, right, which is 15 feet. Okay, so I want to solve for x. I can't use x and y, x inside y, because I don't know neither one of these, right? So I need to use something that I at least know. So I want to solve for x, so that must mean I have to use my hypotenuse, right? So what's something that uses the opposite in hypotenuse? Well, if we look back up at our previous notes, we see that sine actually uses the opposite in hypotenuse. Okay, well, this will be sine of theta degrees is equal to the opposite divided by the hypotenuse. Okay, well, sine of theta degrees, what's our theta degree angle? We said it's 30, which is equal to the opposite. What's our opposite side? X divided by my hypotenuse, which is 15. Here, 15. Well, what can we do here? We can actually solve this like a portion by putting it over 1. Then we can cross multiply, and I'll have sine of 30 degrees multiplied times 15 is equal to x. Now, in the other cases above, we actually had to solve for x in here by dividing both sides by a cosine of 29 degrees. But in this case here, x is already solved for. So we have sine is equal to x times x is equal to sine of 30 degrees times 15. And if you substitute that, plug that into your calculator, 15 should go first. Just remember that 15 should go first. So if we actually do 15 times, let's see, times sine of 30 degrees, we'll end up with 7.5. Exactly. We're going to end up with x is equal to 7.5. Okay. Now that I know x, that's equal to 7.5, let's find. But now that I know x is equal to 7.5, let's go ahead and find what y is equal to. Well, I know that x is 7.5. I know that my hypotenuse is 15. So what is y? Well, y is the adjacent side, so we can use either one of these actually. It really wouldn't matter. Well, just to keep everything how we've been going, let's go ahead and use hypotenuse again. So it'd be, what includes the adjacent and the hypotenuse? Well, if we look back up here, let's see, we see that it's actually cosine, adjacent and hypotenuse. So let's use cosine. Okay, well, I'll say this here. I'll say cosine of theta degrees is equal to the adjacent divided by the hypotenuse. Perfect. Because now let's go ahead and see cosine of theta degrees. What do we say theta was? We said it's 30 degrees. So 30 degrees is equal to the adjacent, which is what? Y, divided by the hypotenuse, which is 15. Okay, perfect. Now we put this over 1 and we can solve this like a proportion here. Well, it is a proportion. We solve it how we solve normal proportions, and we get 15. Now this time I'm actually putting my 15 first, like I should have done here. It should go first. Let me just go ahead and rewrite that real quick, just so you don't get confused here. It should say 15. 15. In some calculators, it doesn't matter. 15 times sine of 30 degrees. Okay, now let's go back here. So we'll say 15. When we cross multiply, we'll say 15 multiplied times cosine of 30 degrees. 15 times cosine of 30 degrees is equal to y. Well, y is already solved for, so we don't have to do any division or anything to get y isolated. So let's do it. 15 times cosine of 30 degrees should give you 12.99, which is the same thing as 13. Okay, so we'll just go ahead and say y is approximately 13. Okay, y is approximately 13. This squiggly line here means approximately. So I've actually answered both of my questions. We actually answered both of my questions. So I found the values of x and y. Okay. Now, we know that, like I said, we know that x is equal to 7.5. We know that y is equal to 13. And if you wanted to check this to make sure it is a right triangle, you know, right triangles actually abide by the relationship a squared plus b squared is equal to c squared. Well, let's see. A squared, let's say 7.5 squared plus b squared. What is b? We'll say b is y, which would be 13, approximately 13. Squared. So since it's approximated, we're going to be a little, we may be a little bit off, is equal to c squared. Well, c squared, let's see, that should be equal to 15 squared. Okay, well, 7.5 times 7.5 will give me 56.25. 56.25. And if I add to that 13 squared, I'm actually going to end up with 2. Let me add that. 13 squared is 169 here. Now when I add these together, so 56.25 plus 169, I'm actually going to end up with, well, let's combine it in a minute here. Let's go ahead and get this side. 15 squared will give me 225, and 56.25 plus 169 will give me 225.25 is equal to 225. Now, we're off by 0.25 because, like I said, this value of y was approximated as really 12.990, but it's actually, so we approximated to 13, so we're just going to be off by a little bit. But basically, you see that this relationship is still true. So that this is indeed a right triangle, and we actually solve the sides by using, solve for the sides by using trig ratios.